Okay, welcome to our talk, A Visit to the Armory, Crafting Your Own Combat Hardware. My name is Mauro and my co-speaker today is going to be Luis Ángel Ramírez Mendoza from my DEFCON group. First of all, I want to say that we are really happy to be here. It's the second time in Iran for me, the first time for Luis and Santiago, the other member of my DEFCON group. And we would like to say thank you before we start. Thank you for the organizers and for all the PostCon staff that made this conference possible. We really appreciate your effort in order to bring us this great event. So let's start. Who am I? My name is Mauro Cáseres, or Mauro Eldridge. I'm the founder of the Birmingham Cyberarms Company, UK, and also the founder of the DEFCON Group 5411, Argentina and Uruguay. I spoke at different conferences around the world, including DEFCON and EC Council Hacker Halted, and across a couple of countries like the USA, Russia, Brazil, Colombia, Iran, this is the second time, United Kingdom, Spain, Peru, Pakistan, India, and Panama, and a couple more. Now my partner Luis Ángel is going to introduce himself. Luis, please go ahead.
Thank you, Mauro. Hello, my name is Luis Ángel Ramírez Mendoza. I work as hardware engineer and Birmingham CyberArm. I am member of DEFCON Group 5411. I spoke at different conferences, including DEFCON and others around the world in places like India, United Kingdom, Spain, Colombia, Pakistan, and now probably in Iran.
Okay, thanks, Luis. Now, about this talk and about our armory. Our company produces different sorts of hardware, combat hardware, as we call it. Different tools and different dongles and different small devices that you may find useful for red teaming exercise or physical penetration testing exercise, and all sorts of offensive security tasks which involve hardware. And we have this kind of showcase we do every now and then that it's called A Visit to the Armory. We are opening basically everything we do, and we offer open source alternatives to our products. So everyone can test them, extend them, modify them, and even build your own combat hardware. This is a way of contributing back to the community. In this case, even though that our armory consists of all sorts of weaponized hardware devices, we are bringing you two different hardware pieces that we have built in the last year. We have actually brought this time some smart movement sensors and some deauthor charges that sometimes they are called jammer charges, but that's not a right term to use. They are not jammers. There's no jamming involved. It's, to speak on a more technical way, it's a deauth. But we'll discuss this in depth, in detail, in a couple of slides. Aside from these kind of tools, we use to build different bad USB devices too. For example, power banks, speakers, keyboards, and even an entire bad USB framework. All of these products are open source, so you don't have to spend a single cent, and you can build your own hardware at home. So hopefully, if you are interested in hardware hacking, this talk might come useful to you, might come interesting. And if you are not so interested in hardware hacking, maybe this talk can bring you some alternatives, some different things to try at home or to try it at your university or at your hacking group. So we hope we can share this with the hope of sharing and involving more people into the hardware hacking scene. So let's start. These are our two products. In this case, they are naked. They do not have, and this is something we did on purpose, in this case, you don't have the 3D printed cases. They are naked. This is in order to appreciate how they are built. And as you may see right now, at a first glance, These prototypes do not seem to be overcomplicated. They do not seem to be ultra complex. And if you are new to the hardware hacking scene or to the hardware scene in general, don't be afraid. This is really way simpler than it seems. This is really way simpler. On the left, you have the sensor, one of the sensors. And on the right, you have the deauthor charge that we will discuss in depth now. Before we go further, I want to tell you again that these projects are open source and you can see them at GitHub. The repository will be updated regularly, adding new items that we disclose as open source. And you're obviously invited, be our guest, on cloning, distributing, contributing, or even modifying these tools. And please, if you do, we are really interested in seeing what kind of product have you come with. We're really interested in seeing your results. We love seeing when people uses one of our products as a base for something different. It's really nice. So let's start with the sensors. Okay, if you want to build the sensors, you will need a couple of materials, but rest assured that these materials are cheap, are easy to find on any hardware store or any electronic stores, and that they are really easy in case you don't have, for example, you don't have any electronic store close to your home, or that you don't have a hardware store near. They are pretty easily found on internet, and they are pretty common off-the-shelf hardware on universities. So if your university has an electronic lab or a hardware lab, they probably have all of these things, so don't worry. The hardware which we will need is the following. An ESP8266, it's a pretty common microsystem with embedded Wi-Fi capabilities, so you can easily build anything that has connection to the internet. It's a pretty popular thing, so you can easily find it. An infrared sensor, in this case, you can use any infrared sensor as long as you know how to bind, how to make it interact with the ESP8266. A 9 volts battery, because this sensor will be deployed on different places where you won't have access to a power source. A power switch in order to turn it on or off. And now the following are optional. A 3D printed case, which we haven't still finished. We are working on building an appropriate case that could be concealable, that could be discreet, that could be hidden easily, and which won't be heavy, which will be light enough for you to be able to deploy this sensor anywhere without it falling to the ground. Now, in case you want to deploy the sensors on certain surfaces or on certain height, you will need an adhesive patch. Any adhesive patch will do. Some people buy adhesive patches from hardware stores or from electronic stores, but you may find this funny, but we were able to deploy the sensors with a double-faced, double-sided tape. So we use duct tape, which has two sides, and it has enough strength to support the sensor. The sensors are not heavy at all. But in case you want something a little bit more, let's say, professional, you can use an adhesive patch. The software is pretty simple too. You can find all of this, and we provide some of these pieces too. For example, the VCA's firmware is a custom firmware created by us, and it's public. So you don't have to pay, you don't have to search, you don't have to apply for a license or register. And the command and control server, it's built on the most common stack, PHP and MySQL. And we have a special web application that can be deployed. Again, this is open source too. For the client, you have two options that we provide on the same licensing, which are the web application, which is the recommended method, or the mobile APK in case you prefer a thick client, which is not bad but lacks a lot of features that the web application has, and we will discuss this in a minute. This is the schematic. As I said before, as you can appreciate in this blueprint, it is not hard at all to build this sensor. This is the Node MCU, this is the ESP8266, and the infrared sensor. That's it. As you may see, it's pretty common. And you don't have to do a lot of tampering with the device itself. It's pretty straightforward. Now, what is the procedure here? These sensors, and remember here that we are using the ESP8266, need a Wi-Fi connection in order to work. They will be provided by the device itself. But now you may have a really smart question. Okay, the device can connect to Wi-Fi. Now, what Wi-Fi connection should I use? That's the point. It depends on the task the operator is taking part on. You can use your own phone, your mobile home, as a Wi-Fi hotspot to share the LTE, 4G, or 3G connection via Wi-Fi. And then you can bind the sensors to your phone, but that will pose a little risk. That is, you won't have a lot of coverage. You won't be able to travel far away from the sensors before they lose the connection. Or also, you can use a portable hotspot that they usually come with USB connections, and these USB connections allows you to connect them to, for example, a power bank or a portable battery. If you use a hotspot, it will provide a longer coverage. Now, another smart question here will be, okay, but what can I do with the SSID for the hotspot or the phone? Well, on the phone, not all brands allow you to use a hidden SSID. But on the other side, a lot of portable hotspots allow you to do so. In that case, the ESP8266 has the option to connect to hidden Wi-Fi spots. So that can give you a little more coverage, a little bit more of defense, of stealth. But it's not a lot actually. Now, both the sensors and the phone or the LTE hotspot will interact via the command and control server. They won't interact directly, and I tell you why in a minute. This command and control server is located outside the premises. And whenever something alters a sensor, it will send a push notification to the mobile phone and will turn itself red, where in the web application or in the thick application itself. Let's see some examples. Take a look, and even though that some of the comments are in Spanish, you're not missing a lot of here in the big picture. This is the database connection. It's pretty simple. We try to build things in a really minimalistic way, in a really simple and small and portable way, so you don't have to, in case of an error or in case that you want to customize something or extend something, you don't have to mess with a lot of code, with a lot of dependencies, with a lot of libraries, with that. Not here. You will have pretty simple scripts. In this case, all the historic data for the sensors will be kept in a database. Here you can see the really small logic behind the buttons. As you may see, depending on the status of the sensor, it will render the HTML button for that sensor in a different way. As you may see, it's pretty simple. It's pretty simple, and it doesn't relies on anything heavy from the backend. Now this is the backend. It's pretty simple. On PHP-MyAdmin you can see it has, in this case, in this first version, only the immediate status of the sensors. But we are, in this new version we are releasing, we are including an historical data record which has the hour where a sensor was triggered. For example, you can see all the historical patterns and data. This can help you if you are doing, for example, a red teaming exercise where you want to see how much time it takes for somebody to walk around a zone or to walk around an office, or how much time does people transit over a certain place. This will give you a lot of information once that you have enough data. Now, this is our firmware that I told you before. Our firmware, to be honest, is just an extension respecting the licensee, the original licensee, from the Space Hans firmware, which is the original one for the Authin chargers. This firmware has been subtly modified to fit our needs and to work with a lot of things that are properly belong to our region, to South America. So some of the original firmware things were not applicable here, were not used, or won't be absolutely useful. So we replaced them, or we have repurposed them. This firmware is open source too. And here you can see the theme client, which is the web application. It's in Spanish because this is the first version, but it basically says sensor 1 disabled. It means that everything's okay, everything's cool, nothing happened. The gray button, it says reboot. Now, this web application has an advantage, and it's that you can natively open it in a laptop or in basically any kind of device, a tablet, a phone, whatever you use. As you may see here, this is in mobile. Now, for some reason, some people prefer other kind of clients, and we provide them too. In this case, we can appreciate what happens when all 4 sensors are activated. It sends an alert, and it's the kind of alert that you want to send is absolutely customizable. So you can say, okay, be silent, or okay, do a lot of noise, or okay, do this or do that, depending on the output or on what sensor was activated. Now, as I said before, if you prefer for some reason a thick client, we have that too. Obviously, as you might see here, it's pretty poor compared to the UI that provides the web application. This is mostly because of the frameworks, the SDK properties limitations. So we prefer to develop the web application instead. This is for scaling purposes. You can see a sensor, the phone, and the hand. As you might see, it's not pretty big to handle. The battery, that's another thing, but that's why we use a 9 volts battery, which is pretty small too. A funny thing is that the battery sometimes it's heavier than the product itself. Here you can see a high resolution photograph. In this case, you might see that this is a test device. You might see that they are different. One of them has a bigger board beneath the GSP8266. The other one has a short one. The cables are still attached with glue, with different tamperings. This is not the final product. The final product has a special case printed in PLA to be as light as possible. And also, we are trying to build something integrated, but sadly, it will take some time, probably 1 year from now. Our attempt is to build a product that doesn't have this kind of cables, doesn't have bigger or shorter boards beneath, and that can fit entirely on a 3D printed case. But for now, this is our first attempt at it. Now, you might say, okay, why should I use this sensor instead of some sensor provided by a vendor or by a well-known brand from a really good seller? Okay, these are our advantages. This product is open source and it's affordable to build. Also, if you want this product and you do not know anything about hardware, and you say, okay, I'm going to ask a partner at my university, I'm going to ask somebody at the hardware store, or I'm going to ask one of my professors to build this hardware for me, I can assure you that they won't charge you a lot for this. It's pretty easily doable and it's pretty straightforward. Also, this is scalable and extensible. In these first two versions, we are working with 4 sensors, but we are now working on making them extensible, scalable. Scalable, I mean that you can add as many sensors as you want. You want to have 12, you can. One of them broke and you want to have 11, it will be easily removed from the web application, and so on. Extensible in the way that you can do anything you want with this. You are not tied to a specific hardware. You can just add another piece of hardware, wire it, solder it, and say, okay, this now does another thing that wasn't intended to in the first place. Also, the user interface is pretty small, simple, and intuitive. You don't have to install anything on your client. And to be fair and honest, it's really, really cheap to host the command and control server. Even, I'm pretty sure that the free tiers or the most cheap tiers, the cheaper tiers at any cloud hosting provider can be more than enough to host this command and control server. And the most important thing here is that you are not tied to a single vendor-locked response. For example, if you buy a product from a well-established vendor, they will say, okay, this product does the following. You have a set of predefined options that maybe they are not what you are looking for, maybe you want something different, maybe it's not enough for what you're trying to do with your sensors. The most common things you are allowed to do is ring a bell, sound an alarm, and things like that. Send me a notification, but it doesn't go out of that way. If you want to do something different, that's not your lucky day, actually. Now you can trigger any response, and you can extend the sensor as much as you want. You can add any software you want. Remember that you're working with open source software, and to a certain extent with open source hardware too. You can add not only software, you can add hardware. As I said before, you just wire it, solder it, and you're pretty good to go. Now it's time for the demonstration of how it works. Okay, let me get play to the video. This is the web application open up in a laptop. 4 sensors. As you might see, they're still different from each other since this is the first release we have done. We touch 1 and automatically it reacts. 2 automatically reacts. A third one and it reacts again immediately, and the 4th one triggering the alert. As you can see here, we don't have any lag, any delay, we don't have latency between the devices and the laptop. We are experiencing a maximum of 0.7 seconds of delay, no more than that. We try to minimize the network dialogue. We try to minimize the interaction needed for this action to be triggered, because we understand that when you're doing a red teaming exercise or a physical penetration exercise, you need to have fast answers. You need to be sure about what's happening. You need to be conscious about what's going on around. So this device needs to talk the least possible on the network, because we need fast responses, and we managed to achieve it. So okay, this was the demo for the sensors. And now my partner Luis Ángel Ramírez is going to talk about the author charges, which it's a pretty interesting device that he has built for this talk. So I'm leaving you in good hands. Luis, you can continue, please.
Thanks, Mauro. So the next artificial way are going to show Wi-Fi that checker. In order to build this device, you need the filing component, include both software and hardware. On the hardware side, we need an USB into CCs, an USB power bank, a power switch, a cassette 3D print, which is optional and not shown in this tab, adhesive patch, or any other adhesive compound. Now, on the software side, we'll need one of the filing to staining. Specific home firmware. This is the classic one, which works perfectly fine out the boss bed, provide pretty much the file item and configuration command we was set up. PCA firmware patch. This is a modified firmware patch build, which provides some extra drilling specific capability like milking inside from popular national ASP. Regardless of your choice, you will be able to be the chart and lesson basic feature. To run the software, you will assemble new Arduino ID so you can pair firmware to ASP82C6 device. This is a way of the classic firmware bringing the original order. Is bring or CC postponed and will allow you the app Wi-Fi device. So what is the app? We'll explain it simple. The app for the authentication attack. This is an attack than the current Wi-Fi negotiation duping the line between two devices, say for example and cell phone and the router. This should not be can you with jamming. The Wi-Fi protocol contains the provision for the authentication frame, setting the frame for the access point and station is the way of disconnecting a specific device. Any attacker can spook and the authentication firmware and send in the router with unfake MAC address, disconnecting a suspect victim. This attack can be carried out with the easiest to graphical web user interface. The firmware with Adobe Key scan for available access point, provide and list and load the attacker to schedule a specific attack routine in the uninteractive way. Here we have an sample of the most popular attack, the bacon flu and the Death attack. The first and is named Seagulls and Flow, which meant massive sending requests. In this case, and charger will flow the network with weekends, which are Wi-Fi authentified. For adapter list on the third menu. This will send an enormous amount of beacons, which translate into a lot fake Wi-Fi the router listing in your device interface. This can lead to confusion on the disruption of normal operation depending on how it is carried. The second attack in the depth which we will explaining before. An attack sent and the depth frame with a spot MAC address, which belongs to another which device. The router receives and authenticates the victim instead of the attacker. When coordinated, this attack can effectively interrupt normal operation for given victim. This is the final product with the dream print case, which is still under development. It is lightweight, small and silent. This is a reason you can easily deploy this hard virtually anywhere, creating chaos in matters of seconds, while making is hard to find. From an operating point of view, this tool shines the way some critical penetration testing routine exercises are carried out. As you can see here, the device is fitting to laptop. The sizing is pretty comfortable to be put hidden somewhere and to also feature a good battery which will provide power to display for a good number of hours. Here a demo. Mauro will make some comment about it.
Okay, let me talk a little bit about this demo, about the charges. Before we start, let me tell you, the computer on the left is the attacker. The central device that you can see there is the author charge. And the device on the right, it's the victim. Now, this is what we're going to do. We are going to connect to the internal device Wi-Fi connection, which will provide us access to the VCA's firmware, which is based on the Space Hands firmware, which was originally intended for portable Wi-Fi deauthers. A pretty nice device which I recommend you to take a look at. Pretty cheap to build too. So now the victim is connected to the internet. Oh, sorry, it's not connected. Now we are going to launch the first attack, which is a beacon flood attack. What is a beacon flood attack? It will basically send a lot of fake networks that actually do not exist in order to flood the Windows list of available Wi-Fi connections. Sometimes you can mess up with different machines, with different environments, and even make copycats of a same SSID. That's the list. As you can see, there are 4 connections only. Now, once the device starts processing and starts building and broadcasting fake Wi-Fi IPs, you will see this list becoming populated. The point on the beacon flood attack is to first to disrupt the operations, and you can see here there are a lot of different connections appearing. And on the second hand, it's pretty good once not for starting an attack, but for continuing an attack. You can disconnect somebody and start flooding with different fake IPs in order to make him slower in recovering from the attack. The point on the beacon flood attack is confusion, nothing more than that. Now, once the victim has been disconnected and tries to reconnect, it automatically connected to a wrong IP, to a fake beacon. And obviously, once you try to connect, sometimes you manage to connect, but nothing comes back. The connection will always be interrupted. That's the idea. The idea of the beacon flood attack is to support the original attack. Now, the machine has recovered the connection, it's loading YouTube, but we are not going to allow it. So we are sending a deauth attack. The deauth attack will once again disrupt the connection. Now, as you may see, the connection has broken. So the person, the victim, can say, okay, I'll reconnect, but then we'll send another beacon flood. What happens then? The victim will try to connect to its original Wi-Fi connection, say for example test Wi-Fi, but it will be unable to do so because test Wi-Fi will still be sending the auth packages, sending please disconnect this device has to be disconnected. And on the other hand, it will try to access another SSID with the same name. Then it will happen as I said before, it will connect to the charge, and the charge will reject any incoming or outgoing connection. So it's basically as if you have never connected. It's like actually not being connected to anything. That's the point of the charge. Again, take a look at the device. It's still on development. It has the biggest battery available. When we deploy this on the field, we are expecting to use 9-volt batteries, which will reduce the lifespan of the device, obviously, will reduce the activity time, and we won't have this giant board beneath the ESP8266. We'll try to build our own circuit, or at least to get a really good case to be light enough to hide this element. The real danger of this element does not come from its capabilities only, but comes also from your creativity. If you're a creative person, you can hide one of these things under a desk, under a chair, on a really high place, so all the exercise will be really more interesting because nobody will be able to find the source of the network disruption. So take a moment to think about it. So, wrapping up what Luis has shared and the demo that I have spoke about just a second earlier, let's talk about the advantages of this charge over the classic deployment model. This model is powered by batteries, so you can actually make it portable, natively portable. Our custom firmware has translations, common local SSID names for faking local internet providers, and simplifies certain operations. Remember that the original author has built this product for his region. So we have to take some licenses and do our own job on adapting this to our region. And you can do so too, without too much hassle. Now, the custom discrete case that we are developing will allow, as I said just a minute before, to have an easy and free deployment. Think about adding an adhesive patch and sticking this charge to different surfaces. Where will you hide this thing? Where will you try to deploy this in a stealthy way? Windows, walls, doors, furniture, and wherever you want to think about. We have even played with the idea of having a 3D printed, or actually buying one, a light switch and hiding it inside the light switch. We are pretty curious to see how people will react to something hidden in that way. Also, the standard size allows all sort of cases to be used. As I said before, a wall socket, a light switch, electrical boxes, vents, air fresheners, and even remote controls. Think about it for a second. If you're creative enough, you can hide this thing on almost anything you have at your home. A hardware, a mouse, a keyboard, all boxes, wherever you think, just name it. Now, our conclusions. Since the arrival of the new embedded hardware and obviously the infinite combinations it provides us, it's increasingly easy to create these implements to our liking. And obviously it's increasingly easy for you at your home or university to modify them and extend them, or even by creating something absolutely different. The use of this technology, when combined with open source software, gives a wide spectrum of movement and flexibility for creators. You can create anything you want. And not only the final result is cheaper, but the product's lifespan can be virtually infinitely extended. Remember that sometimes what happens with big vendors, with big brands, is that their products hit the end of life pretty soon, especially in countries like mine, for example, in Argentina, where these products are not available on the same day they are released. You have to wait a really long period to have your hands over new products. Sometimes when you have access to them, they are really expensive. You buy them and you don't want to hit the end of lifespan because it was a really hard to buy thing, really hard to maintain, really hard to buy licenses. So when the vendor says, okay, I won't support this device anymore, it's really hard for our users. So by using open source software, we can avoid this, which is the major roadblock we have on the hardware industry. Now, we really hope you liked our talk. We want to invite you to follow us on Twitter to engage with any questions, suggestions, or any project you want to share or you want to have us onboarded. You can absolutely contact us at Twitter. Larm182Luis is the Luis one. Now Mauro Eldridge is mine, and DC54111 is our DEF CON group Twitter. And on GitHub, these are our handles. So if you have any question, we are more than happy to answer them. Once again, we want to thank Mir Saman and all the PostCon staff and all the PostCon organizers, which have done a pretty nice job on this conference, and we are really happy to be invited. We really hope to see you again in another edition. Thank you.